So a little bit of the background. So from the 1930s through the 50s, we installed what are called traffic circles or rotaries. There are quite a few still remaining on the East Coast, right? And so you have, Colorado in general, and Estes Park, I'm sure, has folks from the East Coast who've moved here or visit here or live here part-time. And, we used to have public meetings and people would come in and say, oh my God, don't do those rotaries, they're horrible. And some people are like, oh, they're fine, I don't mind them. But the key is that, they're very large. They were based on a very different design methodology. They were the precursor to the interchange that we have now. And so they worked great with Model Ts and Studebakers and much less traffic and slower speeds. But they don't work that well as time went on, as traffic went on. So the image here in the bottom right shows about a 600-foot diameter old traffic circle that was replaced in New York with a modern roundabout that's about 200 feet there. So let's talk about what is that. What is that? So we have the benefit of the science and the engineering that went on in the UK. So we stopped building them in the late 40s in the US, and we have signals. That's what we see in every place across really most of North America. The UK, they didn't abandon. It's a small island, lots of traffic. They had a national imperative from the post World War II. They had a lot of more cars on the roads and lots of congestion, many different sizes and shapes of circles. So they kept researching them and studying them. And in 1966, they decided the first thing we want to do is take circulating traffic and not have circulating traffic stop or yield to entering traffic. So they did some research. They say, if we make entering traffic yield to circulating traffic, we're going to unlock our congested circles that we have. And so as the story goes, one weekend they went out in different regions and they sent the crews out and they switched the yield sign from circulating to the entering. People went to work Monday morning and they thought, where's all the traffic? They thought it was a banker's holiday or something because the congestion went way down. So that was the first step to what's referred to as a modern roundabout. It was in 1966 in the UK. And the Brits kept studying them. And we're not going to get into the details, but significant design research and experimentation was conducted over the course of many decades, and in particular, through the 70s, with track experiments and modifying existing projects and more track experiments, leading to design methodology that we use today, which is these are the foundational elements to include speed control. There's angles of entry, there's view angles and sight distance issues. And these are all captured in our federal highways, or rather, it's the Federal Highways Roundabout Design Guide, if you will. So at the end of the day, roundabouts, began to get implemented in other countries through the 1980s. The first U.S. model roundabout was in the 90s here in North America, in the U.S. And so at the end of the day, they're circular intersections designed to control traffic, just like a signal. And we have methodologies and analysis and design to allow us to design for the site, for the traffic that you're dealing with. So there's a little bit of the, from 1990 of a couple of roundabouts, and that we're building more and more in North America. So one of the things, early on is, show me an example of a roundabout like this one that we're doing here. And here can be anywhere in the country. And as it turns out, we're putting roundabouts in lots of different contexts. Essentially, where there's an intersection, a roundabout may be a potential viable alternative. Sometimes they're putting in cultural and using them for public art in the Central Islands and historic districts and just plain old congestion relief. This is a project here for economic development to promote the growth of that community. Here's a project on a campus, so lots of students, lots of pedestrians, lots of bicyclists in Portland, Maine. Urban revitalization, complete streets type projects that are being used there as well. They're being used in transitional speed roadways and high-speed roadways. I was involved with some of the first high-speed applications. The key is to address the driver's needs on the different roads, right? So you have different design methods and principles that you apply depending on the context of the site you're working on. Yeah.
What's the speed that would qualify a high speed?
So high speed, like quote high speed, is greater than 45.
Okay.
And then 45 is sort of a transitional speed. And lots of times it's posted 45, you can people are driving 55 and that kind of thing. So
Thank you.
yeah. Interchange ramps, roundabouts in series. So it's all based on roadway, traffic, transportation engineering, and the specific roundabout engineering that goes along with it to make these projects work and work well. Corridors, here's a project in Anchorage, Alaska. Nice thing about this project is often with roundabouts, you don't have to widen the road. The needs, roadway widths are often predicated on the needs of signals along the road. You need the 2 or 3 lanes to queue the cars up so when the light turns green, you can get them through. With roundabouts, they operate differently. In addition, you can see here, this is a large grocery store with a right in, right out. One benefit of roundabouts is from an access control perspective and a business access and circulation perspective is you have equal priority if you're making a U-turn or if you're going straight or right or left. And so you can take advantage of some of these unique operational characteristics of roundabouts and take advantage of those for different sites to improve circulation access to businesses. You know, moreover, this road didn't need to be widened. We didn't cut into parking. We had less costs, less impacts as a whole if this was compared to 4 signals along that corridor.